8.5 from Math 70. This is notes section number 1. You can see at the very first part here, the zero product property. You think about that, product means multiply, and we're talking about 0. So anytime we get an answer of 0 when we multiply two numbers, you think about that, and I think you already know this intuitively. Then this means that either the first number is 0, 0 times some number is 0, or the second number is 0. That would get you an answer 0, or maybe they're both 0. So that's the zero product property, just a fancy way of saying if you multiply to get 0, then at least one of the numbers has to be 0. So here we are when we get into the problems where we're going to solve. I'm looking at this situation that we have right here, and I have parentheses with some stuff in there and some stuff in this parentheses, but this really, it equals 0 when we multiply these two parentheses together. So what that means is that either the first parenthesis is 0 or the second parenthesis is 0, or they're both 0, just like we had up here. One of these piles has to be 0 for it to equal 0. So what we're going to do is we're going to say, what if this first pile is 0? So x minus 2. What if x minus 2 equals 0? Well, what would x equal if x minus 2 is 0? Looks to me like x would equal 2. So if x equals 2, then that would make that pile be 0. Now let's try it for the other one. What would make x plus 5 equal 0? Well, I kind of set it equal to 0, solve for x, and I would get that x must be negative 5. So you can kind of see this, it should make sense. Negative 5 plus 5 is 0. Here I have 2 minus 2 is 0. So that's the correct way of looking at it, but most students will kind of look at this and go, well, you can kind of look at that, and that looks like a negative 2, so my answer must just be a positive 2. And here I see a positive 5 plus 5, so that means this should be a negative 5. And it's kind of a little sloppy, but if you're careful about that, you are exactly right. That the number that this isn't is the one that it's the opposite. It's the one that's going to get us there. So positive 5 is negative 5, positive 2, negative 2. So you can kind of think that way. Let's try B over here. 3x minus 1. This equals 0. What would make 3x plus 1 equal 0? Now this one's not so obvious. We just thought we'd figured out a pattern. This one I actually kind of have to work it out the long way. Set it equal to 0. Solve for it. So x equals negative 1/3. Now this one here, this is that one that kind of followed this pattern over here, where if we set this equal, I bet x equals 6, right? Because if I put 6 in there, 6 minus 6 is 0. And so I'm just going to go ahead and jump to that. X minus 6, add 6, it's x equals 6. Okay? So that is the official, formal way of doing that. Now let's see that in a little bit different context. Here I have my expression a squared plus 7a plus 12, our trinomial. Well, we're going to go back and do like we've been doing for a while. What multiplies to be 12 adds to 7. Looks to me an awful lot like 3 and 4. So if I go a plus 3, a plus 4 equals 0, that is factoring. We just factored. But the question didn't say to factor, it said to solve. So now all of a sudden I have a problem here that looks an awful lot like I did up at problem A or B. So I have these two things that multiply to equal 0, and to solve means what does x equal? Or what does our variable equal? So I'm going to do the same game that I did up here. A plus 3, what gets us to 0? If I subtract 3, that means a equals negative 3. Now you guys are probably saying, well, that's a lot of wasted time here, and that's kind of true. So how about we, on the second one, just say, well, what would a need to be to get us to 0? How about negative 4? What I'm going to do is I'm going to encourage you to do it like this. I kind of don't mind if you just say a is -4. And I really don't mind if you do it on both of them. My concern is, though, and I see this too often on the test, when you get to a problem like we have up here when I go 3x plus 1, and it's a more complicated one instead of this one, if all you're doing is just kind of doing it in your head right here, this one throws students off. So I kind of almost encourage you to do it like this. If you have both of them are real easy, do the first one complicated. I mean, do it the long way. A plus 3 equals 0, subtract 3 both sides. And then do the other one in your head. But this helps you remember that, wait a second, I am setting it equal to 0, and that's where I'm getting that. That's why I can just jump the gun here and do that one. Let's try this one. What multiplies to be 12 and adds to be -8? And if you do your little thing over here, I think you're going to find that x equals -6 and -2. So again, x minus 6 equals 0. If I add 6 both sides, then x equals 6. And then this one is just going to be x equals +2. Okay, so can we live with that? Let's go down here. We have 2 more problems. Not too difficult. It's just the form in which they're written. And we've done this before when we had to factor and we just don't have everything to one side. So let's add the 2x to both sides. And then I'm going to be left with 0 equals x squared. Let's put that 2x in the middle, and then the number term at the end. So x squared, the x term, and then our number term. I have my 0 on the left side, not on the right side, but it doesn't matter, right? We can have it on the left or on the right. I just have to think what multiplies to be -15 and adds to be 2. And I think that's going to be x plus 5 and x minus 3. One's positive, one's negative, gets us a -15. When I add 5 and -3, I get +2. So we're going to set x plus 5 equal to 0, which means x equals -5 after I subtract 5 from both sides. And then the other one is just going to be x equals +3. Problem, oops, there we go, so you can see it. Problem F, I need to have all the terms on one side. It would be easier to move my x squared to the left, but I want my x squared term to be positive, if you recall that. So let's subtract 45 from both sides, and let's add 11x to both sides. And so I'm left with nothing on the left, x squared. Let's put our x term in the middle, and then our 45. What multiplies to be -45 and adds to be 11? This one, boy, 1 and 45. 2 doesn't work. 3 might be one that you'd forget about. 3 and 15 doesn't work. 4 doesn't work. 5 and 9. So 5 times 9, I need it to be negative because the middle term is positive, then that means my bigger number is going to be positive. When I get here, I can't get 11x. There's no way I can do that. So in this case, I'm going to say no solution. Now just be careful. No solution is a nice one to come up with because we don't have to do any more work. But in reality, you want to double check because you might have forgotten about one. One that a lot of people forget about is the 1 times the number itself. And sometimes there's some random ones. Like a lot of people, when they do this, they'll forget about the 3 and the 15. We could have gotten a 12, like if that had been a 12x, and there probably would have been like half of you that would have just made your list be just those two right there, and you'd forgotten about the one that actually would have gotten you the 12x. But here we can't get anything. So moral of the story is make sure to move everything to one side, keep the x squared positive, make your list. If you can't get anything, there'd be no solution.